Good day everyone, welcome to JD's channel. Today, we're going to discuss another topic. Don't forget to like, share, and subscribe for more tutorials. Thank you and God bless. Good day everyone, welcome again to JD's channel, and for today's topic, we're going to discuss all about generated EMF per piece. So let's get started. So for the content, we are going to discuss load at unity power factor, load at lagging power factor, load at leading power factor, and we're going to solve problems with regards to this topic. So let's start with load at unity power factor. So here class, you can see our illustration. So pamilyar naman po tayo sa pag sinabi natin unity. Pag sinabi natin unity, ano po yung ating B phase is yan ay in phase dito sa ating phase current. Yung ating phase voltage is in phase dito sa ating phase current. Ayan. So ito yung illustration natin, and ito yung ating generated EMF per phase. So and then we have this alpha. This alpha is yan yung angle natin. Ano po angle natin between the generated EMF per phase and then yung ating phase current. Ayan po. So ito yung ating formula. Okay, so E phase is equals to the square root ng B phase plus I phase, yung ating RA, armature resistance, ayan po, quantity squared plus yung ating I phase times yung ating reactance, ano po, raised to 2. So yan po yung ating formula for E phase. And then for alpha, which is ito yung angle dito. Okay, so yung tan inverse ng ating I phase multiply by reactance natin, and then yung ating B phase plus I phase tapos yung ating armature resistance. So that is for our load at unity power factor. Ayan, so ito class nakadetalye na dito. So again, ito yung ating illustration, and then we have the E phase which is our generated EMF per phase in volts, yung ating load voltage or yung ating B phase, ano po, load voltage per phase in volts also, yung ating I phase which is the armature current per phase in amperes, yung ating RA which is the armature winding resistance per phase in ohms, and then yung ating inductive reactance of armature winding per phase in ohms, then yung ating angle between the ating generated EMF per phase and yung ating armature current per phase. And then we have also ito yung ating power factor, we have positive theta, okay, if it is leading, and we have negative theta if it is lagging power factor. So ayun class, so tandaan na lang natin yan, kabisaduhin na lang natin yung mga formula na yan po, and we will use it later on sa ating problem solving. So the next one class is ayan, yung ating lagging power factor naman. Load at lagging power factor. Okay, so ito yung ating illustration class. Again, we are so familiar na pagka-lagging power factor. Okay? So, lagging power factor, ayan, wherein yung ating I phase is lag dito sa ating phase voltage. Okay? So, kung anong angle man yan, so depende. Okay? So, ibig sabihin, nag-lag ng ating I phase. And even this one, nag-lag ng ating I phase pa, no? Ayan. So, and then yung ating angle naman between sa ating E phase and yung I phase. So, ito yon yung ating alpha. And then, ito yung ating formula for finding E phase at load. Ayan, at lagging power factor. So, yung ating B phase cosine theta. So, nagkakaroon tayo ng angle dito, class, plus I phase RA quantity squared plus yung ating B phase sin theta plus I phase at yung ating inductive reactance quantity squared. And then, ito naman yung ating angle, yung angle alpha dito sa ating figure, which is tan inverse ng B phase sin theta plus I phase times inductive reactance over ng B phase cosine theta plus I phase tapos yung reactive resistance natin. So yan class, ito na yung ating katulad kanina. So given yung ating figure and the formula, so ayan yung ating mga formulas and the definition of our yung mga parameters natin, which is yung ating E phase, generated EMF, yung ating load voltage per phase, ayan, armature current per phase, armature winding resistance, okay, inductive reactance in ohms, ayan, that's yung ating alpha, which is the angle between the E phase, okay, and yung ating armature current per phase. And then, yeah, leading power factor, we have positive value of theta, and if it is lagging, we have a negative value ng ating theta. Okay, that is the formulas, illustration, and for our load at lagging power factor. We go now to the leading power factor. So, ano ba yung formula natin when the load is at leading power factor? So, ayan class, we all know that leading power factor, meaning to say that our I phase or yung phase current natin is nag-lead or nauna siya. Ayan, nauna siya kumpara dito sa ating phase voltage. Okay? So, mangyayari dyan, so ito din mag-lead. Ayan, nag-lead, tumaas o umangat siya kumpara dun sa ating phase voltages. Okay? And then, this one also. Okay, so, the formula for generated EMF per phase, in this case, class, is ayan, the square root of B phase cosine theta plus yung ating I phase tapos yung ating armature resistance at po quantity squared plus B phase, okay, sin theta minus, ito naman class, nagkaroon tayo ng minus dito, minus I phase times yung ating inductive reactance quantity squared. And then yung ating alpha, which is the angle between E phase and yung ating I phase, ano po yung ating pagitan. So we have the formula in this case, leading power factor, we have tan inverse multiplied by the absolute value of B phase sin theta minus I phase times yung ating inductive reactance over B phase cosine theta plus I phase times yung ating armature resistance. And then again class, this is the formula and illustration of our load at leading power factor. Yan. So, ito naman, nabanggit ko natin kanina. So, same component din naman. So, let's now proceed to our problem solving. For sample problem, ayan, so a single-phase AC generator has a armature winding, resistance, and reactance of 0.2 ohms and 2.0 ohms respectively. At a rated load, the current delivered is 50 ampere at 500 volts. Determine the generated EMF when the load power factor is, so we have three classes. If it is in unity, if it is in 0.866 lagging, and if we have 0.707 leading power factor. So let's now proceed to the solution. So ihanda nyo yung inyong mga ball pen, calculator, and notebook. So tayo ay sabay-sabay magsusolve. So let's proceed. For the given class, we are given armature resistance, that is 0.2 ohms, the inductive reactance, that is 2.0 ohms, and also the current, okay, the IA natin, that is 50 amperes, the voltage, the load voltage per phase, that is 500 volts, unity power factor. We have also 0.866 lagging power factor, and lastly we have 0.707 leading power factor. For the required class, we are going to find the generated EMF per phase at unity power factor, generated EMF per phase at 0.866 lagging power factor, and generated EMF per phase at 0.707 leading power factor. For the formula class, so we have this one is for unity power factor. So yung na-discuss natin kanina. And this one is for the lagging power factor. And then this one is for the leading power factor. So those are the formulas that we are going to use in problem solving. So let's now proceed sa ating solution. So we first solve when the load is at a unity power factor. So ito yung ating formula class, and substitute lang natin yung ating mga given kanina. The BP, okay, or the B phase, I phase, RA, and yung ating inductive reactance. So ayan, so we have 500. Okay, the square root of 500 plus 50 multiplied by 0.2, that is our inductive, the armature resistance, quantity squared, plus 50, that is our I phase, time multiplied by inductive reactance natin, that is 2.0 or 2, okay, quantity squared. So the result is, okay, so we have, yan, I hope na nakuha din po ng bawat sa 519.7115 volts. So ito po class, naka 4 decimal places na, ano po, lagi niyong tatandaan sa ating mga problem solving, sa exam, sa quiz, and sa problem set, ano po, and even sa ating mga tutorials we always round off only dito sa ating final answer with 4 decimal places. Okay, so we go now to letter B, that is 0.866 lagging power factor. So first, we will get the data. Okay, so we have that is 30.00291093 degrees. So, kita nyo kasi, hindi ako nag-round up. So, kung ano man yung lumabas dyan, so yun yung ating gagamitin. And then, i-substitute natin siya dun sa ating formula. Ano ba ulit yung ating formula for this lagging power factor? Ayan. So, yan na po class, yung ating E-phase. Na po, para makuha yung ating E-phase using this formula na ating natakal kanina. And then, substitute lang natin yung ating mga values, yung ating given, and then yung ating nakuhang theta. Ayan, upon substituting, so ito yung magiging result natin. So, 500 cosine 30.00291093 plus yung ating 50 multiplied by 0.2 quantity squared. Ayan. And then plus 500 sine 30.00291093 plus yung ating 50 multiplied by 2 and then ayan, quantity squared na natin. So, the answer, so kindly input. And I hope na parehas tayo ng sagot. Ito po yung sagot natin. And we have the E-phase at 0.866 lagging power factor na 564.5922 volts. Okay? So that is for letter B. And ayan, kindly check. And we go now to letter C. Ayan, so letter C, katulad ng ating nagawa sa letter B, so we first get the theta that will be substituted dun sa ating formula. So here, we have 0.707 leading power factor, and then multiply lang natin siya by, or yan, yung ating cosine inverse to get the theta. So we have 45.00865166 degree. That is our theta. So ito yung ating formula for leading power factor. Ayan. So finding the E-phase at leading power factor, and then substitute lang natin class yung ating mga given and yung ating nakuhang theta dun sa ating formula. So, upon substituting, ito yung ating makita, 500 cosine 45.00865166 degree plus 50 multiplied by 0.2 quantity squared plus 500 sine 45.00865166 degree minus 50 multiplied by 2 quantity squared. And then, input, kindly input. So, the result, ano ba yung ating magiging result? The result would be, ayan, so E-phase would be 443.2253 volts. Ayan. So, kindly check. I hope na tayo ay pareho ng sagot. Okay, class, so that would be all. I hope na you learned something, and God bless you. So I hope na you get something and you learn something from this tutorial, and don't forget to like, share, and subscribe for more tutorials. So thank you, class, and God be all the glory. So thank you and keep safe for everyone. God richly bless you.